Notes 37. There we go. We get to start real stoichiometry today. Let me check my online kiddos real quick. Lucas, Slate, and Veronica. Let me go on the right page. Lucas, Slate, and Veronica. Veronica, Slate, and then Lucas. All right. Okay. I once again have to tell you I'm not normally the person that makes the tests. I did once this year in the last 6 weeks, but other teachers or people outside of our group, make sure everything is okay. Presentation audio. I'm just trying to make sure everything's going right. Jared, your thingy jiggy's hanging out. Thingy jiggy. That's right, thingy jiggy. Hey, I did good. Close enough. All right. We are about to start true stoichiometry. You guys have had like the bits, the how to convert. The only one we've not done is moles to liters. That will come later. But you've had the little bits, and now we're about to throw them all together, and we're about to do, today is only a one-step conversion. Tomorrow is a work day. There are no answers on tomorrow, okay, but tomorrow is a work day. Wednesday, we're going to do 3-step conversions. Please do not be scared. It is a mole mass. Today is a mole, and that is a mole mass. And you guys have done molar mass conversions for a long time now. Most of you seem to be decent at doing it. If you've not asked for help because you don't understand, then it is overdue. And that is what these work days are designed for. Where are you getting it from? How do I do this? How do I put 1 and 2 together kind of thing? We have 2 work days today. I thought that the asynchronous day was the 12th, but it's not. It's this Friday. And that's limiting reagents, I think. So what I will do is I will record myself, upload everything. You should be able to go through it. It's like I'm here, but except digitized. If we have problems, there will be a work day the following week. So next week. So, y'all, you have to be able to balance to be able to do what we're doing today. This is the electrolysis of water. You've got hydrogen gas reacting with oxygen gas. Did I tell it to start recording? Yes, I did. To make water. We have to be able to balance the equation. I personally would already give you a balanced equation at this point. I do not know the individual who makes your CBAs, if they want you to do this first or not. I don't. So how many it's frozen. How many hydrogens do you have on the left-hand side?
It's locked. Yeah.
It's locked? The opener is locked. Okay, hold on. I probably did not. Let me go to off of Earth space to chemistry. That doesn't surprise me. I had such a busy weekend, honestly. Opener. Edits. Hold on, let me fix it. Did I just not open the? Did I just not open the? Well, I opened the thing. Hold on. It's open. Edit. Oh, because it's saying it's February. It's not February, it's March. That's what happens when you've got 28 days in a month. Give me just a second and I'll fix it. Y'all can see what I'm doing. I thought I fixed all this last weekend. Alrighty. So if you refresh, it should be able to open. Sorry. I know it's in the middle of the day, but y'all are my first chemistry class. So it should be able to open up now. With this particular equation, we've got hydrogen gas that's reacting with oxygen gas to make water. And we have to be able to balance, because balanced equations is how we switch from one thing, whatever it is, to another. And they're going to be whole numbers. On the left, we've got 2 hydrogens, and on the right of the arrow, we also have 2 hydrogens, so that's not an issue. The problem lies in the fact that we've got 2 oxygens on the left, and we only have 1 oxygen on the right. So how do you start fixing this? What do? You have to be able to balance. You have multiplication. Multiply the 1 oxygen by 2. It is going to put a 2 in front of the water. That's right. So what does that do to the hydrogen on the right-hand side is times 2, which means now we have 4.
You have to multiply the 2. No.
Correct. So originally we were okay, but now we have 4 on the right, but we only have 2 on the left. So we have to multiply the left-hand side by 2. I'm so sorry if any of you are colorblind. I'm so sorry. But on the left, we're going to multiply the hydrogen gas by 2 to make 4. Doesn't affect anything else. So what would be the missing value? 1. Okay, now I personally have been taught to put a 1. If you go off to do college chemistry, organic, biochem, whatever, if it's blank, it's assumed to be a 1. Okay, but I've always been taught that if there's nothing in the space, that it's a 1, which it is no matter what. Freaking juniper pollen is driving me nuts.
What the heck is
Juniper, mountain cedar, juniper. It's the bad pollen right now. It's making all of our noses itch if you're itching. Oh, it's nasty. Ragweed and juniper. Ugh. And mulberry. That's the other one that gets me nuts. Mulberry makes me feel like I need to go back to bed. All right. Is there anybody that did not pick up the notes that needs the notes? Okay, so we sort of left off, number wise with number 37. I got off the, numerical chain as the rest of the chemistry team, so I'm fixing it. So you're gonna have 237s.
What is it?
We are going to do mole to mole conversions. This is the magic switch from one compound to another from a balanced equation. This is the part that most of my students, and I cut my teeth on chemistry, most of my students are like, I'm stuck. I don't know where else to go. This is the thing that lets you switch between them. You're going to have coefficients, and you may not have a 1 in front of your nitrogen. You may not, because I went back and added that in. Your coefficients are going to be whole numbers. They're not going to be fractions or decimals or anything like that. The way that this is read is 1 mole of nitrogen gas. The G just means it's a gas. I'm pretty sure there's another one on here. There is. G means gas, S means solid, L means liquid, and AQ means aqueous, which is similar to a liquid, normally an acid. So 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas to make 2 moles of ammonia. That's how this is read. We can't see, that's a lot. We can see individual atoms with electron telescopes, but in general, we can't see individual atoms of elements, but we can see moles worth. And in the case of nitrogen gas, which I don't have in front of me, in the case of nitrogen gas, 14.01, so 28.02 grams per mole of nitrogen gas reacts with times 2.01 grams of hydrogen gas to make whatever those add up to make that many grams of ammonia. But these coefficients should be whole numbers. We don't use fractions, we don't use decimals, they're all complete whole numbers. Get more of that whole. Next page up here. Now, I know when I was building your notes last weekend, not necessarily today, but when I went to mass later this week, I put extra stuff on top of these notes because that's the way that I teach them. Does anybody still need this one for any reason whatsoever? No. All right, so the this nasty word stoichiometry that everybody's sort of been freaked out about. All it means, don't be scared about the phrase stoichiometry. All it means is switching from one unit to another, like going from feet to inches. That's all it means. It's just in chemistry, we go from moles to grams, eventually, I have not done this, eventually moles to liters, moles to particles, possibly particles to atoms. That is what stoichiometry means. Please do not be scared of this big word. What lets us switch from one substance to another is a coefficient. Now, right now, all we've done is the same substance. We've gone from moles to grams. We've gone from moles to molecules. We've gone from molecules to particles, like atoms. But it's all been gold, or it's all been sodium chloride, or it's all been sodium hydroxide. It's been the same thing. I'm about to teach you how to switch from one thing to another. That's the difference. So far, what number has the mole always got? 1. That's not true anymore. If you go from moles to grams, moles to liters, moles to particles, the mole gets a 1. If you go from moles of one substance to moles of a different substance, then you have to take a look at these coefficients. If you don't remember how to balance, that's what tomorrow is for. Tomorrow is a work day. You have to be able to use a balanced equation to be able to go from salt to maybe sodium hydroxide or water. I have no flippin' clue how rough your next CBA is going to be. I don't know until you guys take it, because you're my first chem class. I don't get to see it. Don't. So these numbers that we put in front of the different compounds, these coefficients, this is what's going to let us know, or what's called a mole conversion. Because until this point, moles always gotten 1. That's not necessarily true when it comes to coefficients. Right, how many moles of ammonia? Ammonia is NH3, can be produced from 1.75 moles of hydrogen. And I'm giving you the already balanced equation. You may not have the number 1 in front of the nitrogen. I was always taught to put a 1 in front. If there was no number in front, it's assumed to be a number 1. I am starting off with 1.75 moles of hydrogen. That is my starting point. And if you'd rather do this as the factor method where you use the parentheses, you can. It's the same thing. You're going to notice that I do not drop a 1 underneath this anymore. It's assumed it's over 1. It's just the way I was taught. I don't want to be in moles of hydrogen. You can't see me pointing online. I don't want to be in moles of hydrogen gas. So where does this unit have to go to cancel out? It's going to go down here. And what are you trying to change it into? Moles of what? No. Wait. Yes. Moles of ammonia, which is NH3. Up until this point, the mole has always gotten a 1. That is not true anymore. If you're going from moles to grams, moles to molecules, which we have not done yet, moles to liter, the mole gets a 1. If you're going from moles of one thing to moles of a different thing, it comes from the balanced equation. So according to this, and I can't even remember which one I do first, we've got hydrogen and we've got ammonia. What number's in front of the hydrogen?
2.
And what number's in front of the ammonia?
2.
That's where you're going to get it from. You multiply anything on the top, and you divide by anything on the bottom. The problem is, when do you have to use parentheses? In this case, because we're only dividing by one thing, you don't have to. It should be, and I'm going to cancel stuff out. Moles cancel. We're going to do 1.75 times 2 divided by 3. And then when I round it, and I'm pretty sure it's more than that as far as numbers are concerned. When I round it out to 3 sig figs, because 1.75. It rounds to 1.12 moles of, in this case, ammonia. When, y'all, I've taught chemistry more years than I've taught anything else. When it comes to stoichiometry, when people get stuck, it's how do you switch from one substance to another. You are literally using the coefficients from the balanced equation to figure out how many of each you need. Let me close this and check how long it's been. Anything on the top is what, this is a giant division line. Okay, so anything on the top times each other divided by anything on the bottom times each other with parentheses if there's more than one. Right now, you only have one, so you don't have to use parentheses. If you're dividing by more than one thing, then yeah, you gotta use parentheses. Let me check on mine real quick. And I thought that we had our in synchronous day, I thought was with the orthodox. You're okay, Declan. I thought our asynchronous day was the 12th, and I was wrong. It's this Friday, which should be I don't know if it's percent yield or if it's limiting. I think it's limiting reagent. Yes, go very quickly. Let me check on mine here real quick. We do have 2 work days built in to this 6 weeks. I know the work days help y'all a lot. Alexis, Declan, Lucas, Slate, and Veronica. Got Slate, got Alexis, Lucas. Okay. Now I know that y'all love when I give you answers. Tomorrow's workday does not have answers, but the one on Thursday does. If you do not show your work, I cannot give you credit. It's just the way it works. All right, how many moles of oxygen are required to completely react with 8.25 moles of acetylene gas? Now, here's your, oh, they can't even see me pointing online. Okay, so here's oxygen. Here's the acetylene gas. They are both reactants, which is why I know that is the acetylene gas, let alone the fact that this is, oh gosh, I have no idea what I just did. Push the wrong button on the remote. Go down. It started over from the beginning. I can get to the right slide. But we're past this one. Here we go. All right, so things that react are reactants. They're on the left side of the arrow. The things that are produced are the products. They're on the right-hand side of the arrow. In this case, we want to know how many moles of oxygen, which they can't see me pointing. I just screwed this up with my, how many moles of oxygen are required to react with the acetylene gas, which is the C2H2. The letter G just means it's a gas, S is a solid, O is a liquid, AQ is aqueous, which is similar to a liquid, but it's not water. Looks like water, but it's not. Drink it, you're gonna die. So I'm starting off with 8.25 moles of the acetylene gas. I don't care what I'm asking you to convert. What should go down in the next step? The whatever, take off the number, whatever the unit is. In this case, moles of the C2H2, which is acetylene gas, needs to go down. Do not leave off the compound. Don't just put moles, don't just put grams, don't just put liters. Make sure you're including the substance.
So,
What are you trying to change it into? Moles of what?
Oxygen.
but, is.
You're trying to solve for moles of oxygen gas. My hardest part of teaching y'all chemistry, in this case, the stoichiometry, is the process. What are you starting with? And what are you changing to? And what are the links to be able to put everything together? And yeah, the rest of this class is math.
So,
What? No, ask.
no, I'm sorry.
What the heck was that? A giant on the ceiling? So these numbers no longer, it's always been the mole gets a 1. Always the mole gets a 1. That's not true anymore. When you go between different substances, they come from these coefficients. So what number is in front of the acetylene, the C2H2?
Dos.
A 2. What number's in front of the oxygen?
Five.
A 5. You multiply things on the top. Once again, this giant division line, this line is division line. You multiply anything on the top and you divide by things on the bottom. So you would be 8.25 times 5 divided by 2. If you're dividing by one thing, you don't need parentheses. If you're dividing by more than one thing, you do need parentheses. And then I'm going to round to 1, 2, 3 numbers. 8.25 has 3 true digits. And in this case, I'm going to have 20.6 moles of oxygen gas. I was always taught to go ahead and reduce if you could reduce. You don't have to do it as long as you know how to push you know how to smash numbers in the calculator. The fewer times you press enter on your calculator, the less chance there is for human error, where maybe it doesn't register a decimal, or you go to push a number and it doesn't register it. These things only understand what you tell them to do. I really need to fix that screen. It has been shifted off to the side. Actually, I think that happened because we had a power outage. Need to fix it. Next one. Same equation. I need 3 moles of hydrogen gas for this to occur. How many atoms of hydrogen would that be? Now, I know this is a 2-step because I'm starting in moles. I have to switch to moles of the different, snap my finger. I have to switch to moles of the different substance using the equation. And then once I'm in moles of the new substance, I'm going to use, in this case, atoms. We're going to be using Avogadro's number. No, I'm going from moles to molecules to atoms in this problem. So I'm gonna drop what I'm starting with in the top left-hand block. Once again, if you need to put a 1 underneath it, put a 1 underneath it. I don't, I leave it blank. That's the way that I was taught. But I'm starting with 3 moles of hydrogen gas. I'm gonna drop moles of hydrogen gas. What I'm trying to get to is atoms of hydrogen, but hydrogen gas is not an atom, it's a molecule. So I have to go to molecules of hydrogen gas first. Then I'm going to drop molecules of hydrogen gas, and I'm going to change it into atoms of hydrogen gas. Like I've said repeatedly, the hardest part is teaching you the process. Once you understand the process, chemistry is so easy. It's so simple, especially if you have an analytical brain like I do. For moles of hydrogen gas to molecules, 1 mole has how many pieces? What's the special number that we keep talking about? Avogadro's number. That's exactly correct. And then 1 molecule of hydrogen gas has how many hydrogens in it? 2. It's a subscript. I just didn't put the conversion factors on the top. So I can get rid of moles of hydrogen gas. I can get rid of molecules of hydrogen gas. You're going to multiply everything on the top divided by 1. So the 1s are going to go away. 3 times 6.02 times 10 to the 23rd times 2 is going to end up being 3.6 times 10, or E. I don't care if you write E. I understand that. 24th hydrogen atoms. If I give you a balanced equation, this is a piece of cake. If I make you balance it first and you don't balance it the right way, I don't care how well you set it up, it's going to be wrong, which is what tomorrow's workday is for. I'm probably going to help you balance a few of them. There are no answers on tomorrow's assignment. There are on the workday for Wednesday, because math can be a bear. And like I've said, if you're confused and you don't ask for help, there's nothing I can do. Ask for help. Oh, and the mole train thing from Friday is still a test grade, and it's due today. Some of you already turned it in and you got it right. Some of you got the bulk of it right, but you got the murderer and the murder E wrong. Last bit, molar mass. So we're about to do 3-step mass conversion problems. You've got to be able to do molar mass for whatever it is. Both the starting substance and the ending substance. It's still the same thing. Still the same thing. What lets us link them together is what we've done today, which is the coefficients to be able to go from mole to mole. That's the magic piece. To go from one place to another is the mole. In this case, aluminum sulfate, there are 2 aluminums. I can't speak today, y'all. 2 aluminums. Each one is 26.98. We're using 2 numbers after the decimal. There are 3 times 1, which is 3 sulfurs. Each one is 32.06. And then there's 3 times 4, which is 12 oxygens. Each one is 16.00. Y'all, I was not kidding when I said you're going to be using molar mass for the rest of this class. You have to be able to calculate molar mass. In this case, when I multiply each one out, when I add them together, the molar mass of aluminum sulfate is 342.14 grams. As long as I didn't make a mistake pulling something off the periodic table and multiplying, because y'all already know you're my first chemistry class, and if I make a mistake, it's gonna be y'all where I catch it. Before I turn the light back on, is there a question specifically how I did this slide? You must be able to calculate molar mass, or you will not be able to calculate anything else in this class. Brandon, wake up, thank you. Okay, let me go on. You did not pick up today's assignment and needs a copy of it. So what you're doing today, let me phrase this. What you're doing today is the equations are already balanced, and I should have made sure that all of the coefficients are on there, and they are. And you're switching from one substance to another. This particular switch, this mole to mole, using the balanced equation, this is where all of my students get stuck. They're like, I don't know what to do next. You have to flip-flop from one thing to another. Mole to gram, mole to liter, which we've not done, mole to particle, the mole gets a 1. That is not true now. When you're going from moles of one substance to moles of a different substance, you've got to use the coefficients from the balanced equation. And like I said, at the beginning of this semester, last 6 weeks, if you can't make your formula correct and you don't have the right subscripts, you're doomed. If you don't have the right formula, you can't have the right skeleton equation. If you don't have the right skeleton equation, you don't have the right balanced equation. You don't have the right balanced equation, you don't have the mole ratio. You don't have the right mole ratio, which is, it's not the slide. The coefficients, you can't do any of the stoichiometry. And I know most of you are like, I'm never going to use this in my life. This is stupid. If any of you take any kind of pharmaceuticals in any way, shape, or form, yes, it does.
I take 20.
I don't care how many you take. I take a statin for cholesterol medication. Any kind of pharmaceuticals, yes, this does affect your life. Because if they get this crap messed up, you die. So, anyways, let me stop this. And I always hear that, especially with chemistry. This is never going to affect me. This is so stupid. No, it affects your life. Let me stop the recording here.